Welcome to Unit 5, Session 1, TRIZ Design Principles. The Theory of Solving Inventors' Problems by Soviet engineer Genrikh Altshuler, maybe, in the 1940s, 1950s. It's interesting to note here that we're talking about inventors' problems. You can hear echoes here of QFD. If you remember, QFD in the roof of the diagram identifies design conflicts. So there's some understanding here that what we need to produce, what the customer requires, some of those requirements will be in conflict, and that's recognized here. We can also see that Pew, with his design convergence, was thinking about balancing different requirements to come up with an optimum design. So we can understand that there's this general concern that design is not straightforward, that we need to be able to resolve problematic issues or targets of performance. The general idea here with TRIZ is that if we could look at known design solution methods, then we could apply them to our own design issues or design problems or design conflicts. The table below here is saying that level 1, apparent solution, personal knowledge, we might come up with a number of potential design solutions, and maybe a third or so of design is done this way. If we were to go to step 2, then and we had all the knowledge in the company, that is, if we harnessed a number of inputs and came up with potential design solutions, then we might increase that considerably. I don't think we should take these numbers literally, but we would increase the number substantially, and perhaps quite a lot of design is done that way. If we had knowledge of the industry, then again we might get a jump in terms of potential design solutions, but relatively few designs are actually done that way. And as we progress to further up here, all knowledge that might be applied, very few designs, if any, take that into account. But there is the recognition that we might continually improve the number of solutions that might be on offer. The greater was our spread in terms of looking at known design solutions. So that's the part of the idea. Now down here it's saying general principles. We might have our particular problem. We might then look at TRIZ general problems, look at the way that those have been solved historically in some way, and then apply those solutions to our situation. Again, that's the general principle. How would we do this? Well, the thought was that if we could capture these known solutions, then we could analyze them, and we would find that there would be some commonality between design solutions. But how can you do that? And that's largely why the technique failed back in the 1940s and 50s. It sounds like a very good idea, but where do you get these design solutions from? It's not until we get into the 1980s, 1990s, that it becomes feasible to capture patent information so that you could then analyze design solutions that have been applied, in this case, particularly in mechanical engineering. So then we have the capability of computing, where we can analyze all of these patent solutions. And what's happened is that 40 design principles have been proposed by the TRIZ Society, which is now based in America. And we'll see in a little while what these principles include, and then look at how we might apply them to an example. Before we do that though, let's consider again the sorts of conflicts that we have thrown up by customer requirements. For example, if we look at two products here, a bicycle, the customer might quite legitimately be looking for lightweight but high stiffness and strength, and also low cost. Now obviously these three requirements are in conflict with each other. Lightweight, because it's pedal power we're using, and the lighter the bike, obviously we tend to reduce the effort required to cycle. High stiffness and strength, depending upon use. If we were using a bicycle for shopping or camping, we might want it to be quite strong. But there again, you might get lightweight and high strength, but the cost might be a problem. So there's three areas there that might well be, or three requirements that might well be in conflict one with each other. If we then look at a car or an aircraft, again, the customer wants high performance perhaps, at the same time good fuel economy and lightweight. And from an engine point of view, whether a car or an aircraft, those also present problems, and it's not easy to reconcile all of those requirements.